welcome back, everybody, to another episode of What's on My Radar. I am your host, Radar Reed, meteorologist Reed Kisselback himself. Today's topic, another one that we get asked about a lot, is different types of precipitation. Sometimes it comes in the form of an email to us or a social media post where we get clips of it and we go, what is this exactly? So that the goal of this episode is to address that topic. We'll define a couple of precipitation types. And on top of that, too, we'll also go through everybody's other favorite question, which is the precipitation percentage probability. So, when we say 30% chance of showers, what exactly does that mean? So let's start off, though, with precipitation. So obviously, as we know, interestingly enough, although all clouds contain water vapor, not all of them precipitate and drop rain or snow or any other type of precipitation. Those clouds, the reason behind that, may be either too small or short-lived to see that happen. But in addition to water, clouds contain a lot of microscopic bits of salt, dust particles, what we call aerosols, and these materials form what is called cloud condensation nuclei. And so precipitation forms in two ways. The first way is when that water vapor condenses around a nucleus of a cloud condensation nuclei, and we call this process coalescence. It occurs in warm clouds typically with more cloud droplets than ice crystals. And so what happens is the wind pushes those droplets and they collide and become larger and heavier until at some point those droplets become too heavy for the air to keep it afloat and it rains. So typically coalescence only produces liquid precipitation. The other way that we get precipitation, this occurs through a process called the Bergeron process. And this happens when we have moist air that cools high up in the troposphere beyond the dew point, and tiny ice nuclei form and attract supercooled droplets to form snowflakes. So the Bergeron process can result in liquid or frozen precipitation depending on the temperature from the cloud to the ground. So let's dive into it, talk about a couple different types here. Rain and snow are probably the most common types, but there are others. The temperature of the cloud and the air between the cloud and the ground is what creates those different kinds of precipitation. So let's start off first with just our general precipitation explainers here. So we're going to take a look at just rain. With rain that is made of liquid water droplets that falls when the temperatures in the air and at the surface are above freezing, so 32 degrees Fahrenheit. Rain can start as water droplets or ice crystals in the cloud, but always falls as liquid water. Freezing rain, you have a warm pocket, so you start out with ice, it melts, and then the surface is at 32 or colder and it freezes on contact. Sleet, you have a pocket of air that is smaller, so it starts out with ice, it melts, it then refreezes, and you have these little ice pellets that reach the ground. And snow falls when the temperature between the cloud and the Earth's surface remains below freezing. So you look at snowflakes closely, you can see the unique and beautiful shapes. That has a large part to do with the conditions that we have in place. If we move on to a different type of precipitation, this is one that we often get confused with hail. And so I'll touch on this one first. This is called graupel. And graupel is a frosty kind of snow. So what happens with this is snow forms, it falls through a layer of super cold water droplets. They freeze or rime onto the snowflakes. And the end result is these tiny little white pellets that reach the ground. And they often, though, give a bit of a slushy texture to them. So not as hard as what you would see with hail. Graupel, though, we typically see more so in the early winter months, late autumn months, or maybe even early spring when we get some showers and storms to come on through. So that's usually a good indicator there. The other one that we talked about that's similar that usually gets confused is hail. So we'll touch on the hail part right now. So hail, how exactly that forms is inside a storm. There's what we call an updraft. So frozen water droplets are swept up by the updrafts. Additional layers of ice form each time it's swept up. Eventually, the weight of that ice droplet exceeds the force of the updraft, and the hailstone falls, and that's how you end up with hail. Obviously, the stronger the updraft, the larger the hailstone can get, and that's when you start to hear about quarter-size hail or the rarity of golf ball-sized hail is when you have a really strong updraft going on in a storm. There's other types, too, that we can classify. You might hear meteorologists say drizzle. And drizzle is essentially just tiny water droplets that are classified as less than 2/100 of an inch in diameter. And so that's when we have, it feels almost kind of like it's misting outside, right? Drizzle is in between rain and mist in place. And so that's one, you can see that even with a little bit of some snow in the mix, to a little bit of a snowy drizzle outside. The last one I want to touch on too, this is one that you can get a little bit more confused with on your weather app perhaps. And this is just because you look at the weather app, you see some green, maybe even some blue on there, which means you're seeing rain or snow. You go outside and there's nothing going on. And so the question behind that is, what exactly is that? Well, that's called virga. And so in the normal instance, in a storm, we have rain or snow that just falls from the clouds, reaches the ground. Virga is when that precipitation starts to fall, hits dry air, and it evaporates before it reaches the ground. So you see its signature on the radar, but you're not seeing the ground truth. That, again, is what we call virga. And now we get to our last part here of this episode. This one's a shorter one, so no guests for us today. This is kind of why we did this. It also gets a little bit confusing, especially with this later part, as we now go on to the precipitation probability. And so for a lot of folks, I know they wonder what exactly is that. And that's when we have our forecast say there's a 30% chance of showers and storms. What exactly does that mean? So precipitation probability means that we have to get at least 1/100th of an inch of more of precipitation for a specified time period for any given point in the forecast area. So an example that we have is there's a 40% chance for rain this afternoon. That means that there's a 40% chance of rain at any point in the county from noon to 6 p.m. local time. I know it's a little bit confusing, but what it essentially means is that you have a 40% chance throughout the course of the day. If you want to view it the other way, there's a 60% chance that you stay dry throughout the entire time period. So if you're saying afternoon, that's from noon to 6. We'll go to the next part of this. Where exactly do we get this part of the equation? It's defined, so POP, so probability of precipitation, is equal to the forecaster confidence, so how confident forecaster is, so that percentage, and you multiply that by the area that the precipitation is expected to impact. So another example that we can give that gives you kind of the correct statistical result is if a forecaster was 80% certain that rain would develop, but only expected to cover 50% of the forecast area, then the forecast would read a 40% chance for rain for any given location. Another example is if the forecaster expects a widespread area of precipitation with 100% coverage to approach, but it was only 40% certain that it would reach the forecast area, then it would result in a 40% chance for rain at any given location in the forecast area. So certainly still a little bit confusing for some folks, but the thing to note is that there is a chance for rain in that location and any part of that location for the time window. So when we say scattered showers at 30% chance in our region, what we're saying is we cover 14 different counties. Over the 14 different counties throughout the course of the afternoon, there is a 30% chance that 30% of that area could see some showers, which means 70% of us, or maybe the majority of us, could go through your entire day with dry weather. And so that's why when we give these forecasts and we say showers are very isolated in nature, that's where you can get a little bit of that confusion in the forecast. So hopefully that makes sense. Thank you, everybody, for watching today's episode of What's on My Radar. We have a couple more episodes to go with some good content in there. Again, thank you, everybody, for sharing what you wanted to learn more about. We look forward to seeing you again, or if you're listening in, hopefully you're learning something good out of this, and we'll see you next time.